Hi guys, hope you all are doing well. So here in this video, we are going to analyze 5 standard MCQs on stoichiometry for targeting JEE 2021 examination. I can say that these questions on stoichiometry not only useful for JEE, they can also useful for NEET and all other chemistry related examinations. Why? Because the stoichiometry is the most important topic in many chemistry related examinations. So that's why I request you that watch the video completely. If you watch the video completely, you can get a lot from that each and every question, and which will surely helps you in your success. Okay, and if you like this video, click on like and do subscribe our channel for more updates. And if you are further interested, you can visit and join the website chemmasters.online, or you can download the mobile app Chemmasters from Google Play Stores. Okay, now just look at the first question here. If 80 grams of calcium chloride reacts with silver nitrate, how many grams of silver chloride is formed? So these questions are regularly giving on our community tab of Chemmaster official YouTube channel. You can practice them on the community tab or community section. Then you can get the video analysis on each of the 5 questions from each and every topic, so that may helpful for you. Okay, right. As a first step, we need to write a balanced equation between calcium chloride and silver nitrate, so which is going to produce calcium nitrite and silver chloride. So in the reactant side we have 2 chlorines, but in the product we have only 1 chlorine, so we may add coefficient 2 here. So if you add 2, then the 2 silvers are present in the product side, then only 1 silver is there on the reactant side, so we can add coefficient 2 here. Now you can see that on left side and right side of the equation, all of the elements are completely balanced. Okay, so by just using the stoichiometry, we can balance the equation. After balancing the equation, we are going to determine how many grams of silver chloride is produced from that 80 grams of calcium chloride. Okay, now just take 80 grams of calcium chloride into 1 mole of calcium chloride by, what is the molar mass of calcium chloride? 110.9 grams of calcium chloride into, so how many grams of silver chloride is produced after balancing the equation? 2 moles are there. Okay, so 2 moles of silver chloride by how many moles of calcium chloride is utilized? Only 1 mole, so you can write 1 mole of CaCl2 into, what is the molar mass of silver chloride? So that is we need to calculate, that is 1.143.32 grams of silver chloride by 1 mole of silver chloride. So after cancelling the similar terms, we can get the value 207 grams of silver chloride. Okay, so the correct answer is the first one. Here we need to convert the grams into moles and moles into grams, so that is the simplest formula we need to use here. Okay, right. The next one, the second question, 26.17 grams of aluminium reacted with 32.15 grams of sulfur to produce Al2S3. Theoretical yield of Al2S3 and the limiting reactant of the reaction is. So here, as the same step, we need to write a balanced equation between aluminium and sulfur to produce Al2S3. Now simple, here we need to add 2 here and we need to add coefficient 3 here. Now you can see the reaction is completely balanced. Okay, now here first we are going to find how many grams of Al2S3 is produced from 26.17 grams of silver. Okay, right, now just write down here 26.17 grams of aluminium reacting here into 1 mole of aluminium by, what is the atomic mass of aluminium? 26.98 grams of aluminium into, so how many moles of Al2S3 is produced? Only 1 mole of Al2S3 is produced, so Al2S3 by how many moles of aluminium is utilized here? 2 moles of aluminium is utilized. Okay, now so what is the molar mass of Al2S3? So that is 150.14 grams of Al2S3 by 1 mole of Al2S3. Now you can get 72.82 grams of Al2S3. Okay, now we need to find how many grams of Al2S3 can be produced from 32.15 grams of sulfur is utilized in the reaction. Okay, so we can write 32.15 grams of sulfur into 1 mole of sulfur by here what is the atomic mass of sulfur? That is 32.06 grams of sulfur into, now how many moles of Al2S3 is produced? Only 1 mole of Al2S3 is produced. How many moles of sulfur is utilized? 3 moles of sulfur is utilized. Now what is the molar mass of Al2S3? 150.14 grams of Al2S3 by 1 mole of Al2S3. It will produce 50.19 grams of Al2S3. Now you can see that the smallest value should be considered as the theoretical yield. Why? Because here the smallest yield is produced from the sulfur. So sulfur must be the limiting reagent. Okay, because after utilizing sulfur completely, then there will be no further reaction. So that's why sulfur is a limiting reagent, and 50.19 grams of Al2S3, not O3. So just it is take it correct. Okay, so 50.19 grams of Al2S3 and sulfur is the limiting reagent. And what is the excess reagent here? Aluminium is the excess reagent. Okay, right. So fourth option is the correct answer. Now the third question. If 17.6 grams of calcium and 23.8 grams of AgNO3 are reacted, if 12.5 grams of silver is produced, then the percentage yield of silver is. So as a first step, we need to write a completely balanced equation of the reaction, okay, between calcium and silver nitrate. Okay, so which are going to produce silver and calcium nitrite. So here 2 moles of silver and here 2 moles of AgNO3. Now the reaction is completely balanced. Okay, now you can take 17.6 grams of calcium and how many grams of silver should be produced. So we need to find, so 17.56 grams of calcium into 1 mole of calcium by, what is the atomic mass of calcium? 40.08 grams of calcium into how many moles of silver is produced? 2 moles of silver is produced from how many moles of calcium? Only 1 mole of calcium. Okay, into what is the atomic mass of silver? That is 107.8 grams of silver by 1 mole of silver. Okay, so it will produce 94.52 grams of silver. Now we need to find how many grams of silver produced from 23.8 grams of silver nitrate. Okay, now just take it the same method, 23.8 grams of silver nitrate into 1 mole of silver nitrate by the molar mass of silver nitrate, 169.8 grams of silver nitrate into 2 mole of silver. That is here you can see 2 moles of silver is produced from 2 moles of silver nitrate. Okay, AgNO3. Now here you can write 107.8 grams of silver by 1 mole of silver. Now it will be 15.1 grams of silver. You can see the smallest value should be taken as a theoretical yield. Now you can find the percentage yield equals to here you can write actual yield. Okay, so actual yield by theoretical yield into 100. So what is the actual yield? 12.5. So you can write 12.5 by what is the theoretical yield? 15.1 into 100. So here you can get 82.8%. So the correct answer is the fourth one. Okay, the next question. here when 45 liters of chlorine gas reacts with excess aluminum, 165 grams of aluminum chloride are produced. The percentage yield of aluminum chloride yield. So here you can see this question is somewhat different from the previous questions. Here we have given the volume but not the grams. Okay, so as a first step we need to write a balanced equation between aluminum and chlorine gas. So it is going to produce AlCl3. So now you can add coefficient 2, 3 and 2. So now the reaction is completely balanced. Now here 45.0 liters of Cl2 into 1 mole of Cl2 by, here you can take, for the gases you can take 22.4 grams of Cl2. Okay, now so here 2 moles of AlCl3. So to convert them into grams you can take 22.4 grams here. Okay, so 2 moles of AlCl3 is produced from 3 moles of Cl2. Okay, into, so what is the molar mass of AlCl3? 133.3 grams of AlCl3 by 1 mole of AlCl3. Now it will produce 178.57 grams. So here 178.57 grams is a theoretical yield. Now so you can get the percentage yield equals to experimental yield by, so experimental yield by theoretical yield into 100. What is the experimental yield? 165 grams. You can write 165 grams by the theoretical yield is, we have given 170, we have calculated 178 grams into 100, so which will yield 92.7 percentage. Okay, so fourth option is the correct answer. Okay, now the final fifth question. Zirconium iodide is decomposed to obtain pure zirconium. The percentage yield for this process, if 5 grams of pure zirconium is obtained from the decomposition of 45 grams of zirconium iodide is. So as a first step we need to write a balanced equation, a balanced equation for the decomposition of zirconium iodide. So zirconium iodide here. Okay, so which will produce zirconium plus 2 moles of I2. So here 45 grams of zirconium iodide reacting, so 1 mole of zirconium iodide by, so what is the molar mass of the zirconium iodide? So 601.6 grams of zirconium iodide into 1 mole of zirconium is produced. Okay, by 1 mole of by the decomposition of 1 mole of zirconium iodide into, so the zirconium atomic mass is 91.2 grams of zirconium by 1 mole of zirconium, so which will produce 6.82 grams of zirconium. Now the percentage yield equals to the experimental yield, which is given as 5 grams in the question. Okay, so 5 grams, so 5 by the theoretical yield is 6.82 grams. So 5 grams by 6.82 grams into 100, which will produce 73 percentage. So here the third option is the correct answer. Okay, so if you like this video, please click on like and do subscribe for more updates. Thank you very much.